Good morning to all of you. In previous session, we have seen one example for identifying Z transform. We also identified its ROC and we have plotted that ROC by using the in the Z plane. Okay. So here in this session we will be discussing one more example, right, which is similar to the earlier session example that we have discussed, right. So again here you have to determine the Z transform of the signal x of n is equals to alpha to the power n u of n. Okay, you have to identify the Z transform of the signal x of n is equals to alpha to the power n u of n. Okay, so again in this case the given signal x of n is equals to alpha to the power n u of n. So as we know that u of n is a unit step sequence, okay, it is one of the elementary discrete time signal, and u of n is equals to 1 for n greater than or equals to 0, and it is 0 for negative values of n, right? So that means we can simply write it as what it is, alpha to the power n for n greater than equals to 0, right? Because u of n will be 1 in this case and it will be 0 otherwise. Okay, that means for negative value of n, u of n is 0, so this complete signal will be 0. So that means for negative values of n, x of n will be 0, and for positive values of n, x of n will be alpha to the power n. Okay, so the Z transform of signal x of n is given as capital X of Z is equals to summation n is equals to minus infinity to infinity x of n into z to the power minus n, right? We have seen this formula. Okay, so here in place of x of n you can substitute the given signal value, right? That is alpha to the power n into u of n into z to the power minus n will be as it is, right? Again you can modify this equation limit, okay, because this signal exists only for values of n greater than or equals to 0, and for negative values of n it is 0. Okay, so therefore you can modify or eliminate the negative values of n from the summation limit. So minus infinity to minus 1 will be eliminated and n is equals to 0 to infinity will be kept as it is, right? So the new summation limits for this x of z will be n is equals to 0 to infinity, and for these values u of n will be 1, so you can write simply alpha to the power n into z to the power minus n. Okay, so this is the transform that we'll get. Okay, so I'll rewrite this equation. So this x of z is equals to what we have now, n is equals to 0 to infinity, okay, alpha to the power n z to the power minus n, alpha to the power n z to the power minus n. So again you can rewrite it as n is equals to 0 to infinity, you can take n common, so it will be alpha z inverse raised to the power n. Okay, and in previous session we have seen one geometric series, an infinite geometric series, as it was 1 plus a square plus and so on. This can be written as 1 upon 1 minus a, okay, provided that mod a should be less than 1. Okay, so by using this form of infinite geometric series, so this is simply the this is for what, summation n is equals to 0 to infinity a to the power n. Okay, so if it is the equation, so this can be represented as in the simplified form as 1 upon 1 minus a. So in place of a there is value alpha z inverse, so you can write x of z as 1 upon 1 minus alpha z inverse. Okay, in place of a there is value alpha z inverse, right? So provided that this mod alpha z inverse should be less than 1, so if I'm sending this z on the right hand side, okay, so this will be simply alpha less than 1 upon z inverse. So 1 upon z inverse is nothing but z. So that means z greater than alpha will be there, right? That is alpha less than z. It means z is greater than alpha, right? So therefore you can simply write it here at mod z is greater than alpha. So this will be the ROC because the values of z will be greater than alpha in this case. So this is the required z transform. Okay, this is the required z transform of the signal. X of n is equals to alpha to the power n u of n, which is the given signal in the example. Okay, its z transform will be this one. X of z is equals to 1 upon 1 minus alpha z inverse. Okay, so to plot this ROC, again will be plotting the real values of z on x-axis and imaginary values on y-axis, right? And again, to plot this ROC, as the mod z is greater than alpha, we'll draw one circle with radius alpha, right? So from this center, the radius will be alpha, right? And ROC, as ROC is greater than alpha, that means the values of z are greater than alpha. That means it will be the again exterior part of this circle. Okay, so this will be the ROC of, okay, this will be the ROC, that is the exterior of circle. So this figure indicates the ROC plot, okay, for the given or for the obtained Z transform. And as this ROC is exterior to circle, signal is causal, or which is also called as right-sided. So when we are calling it as a right-sided signal, that means values in the signal will present on the right hand side of the origin only. That means on left hand side of the origin there will not be any value present. Okay? So this is how we will be obtaining the Z transform of the given signal and how we are plotting the ROC of the obtained Z transform. Okay. So in next session we'll again discuss one more example on the Z transform. Thank you for joining this session.